All right, it's Healthcare Unfiltered, and I always get excited on Healthcare Unfiltered when I have first timers, right? So when you have a first timer on Healthcare Unfiltered, there are two advantages to this, Sam. Is number one, you actually could get a T-shirt, the Healthcare Unfiltered T-shirt.
Oh,
I
okay.
know, I know, it's a very, very unique situation. Also, if you play your cards right, you probably could get invited again. So, be careful.
Okay.
Um, No, it's a really pleasure to have you with us in today's podcast. We'll do a quick introduction because I've invited you on this podcast to talk about something really, it's the talk of the town every single day, every single town. It's probably for those of you guys who are in AI,
Mhm.
it's very gratifying because literally we are in on the cusp of something amazing. So let's do a quick intro for folks who don't know you, who have not heard you, who just a bit about you and what you do. How did you, just take us through your beginnings.
Oh, beginnings. I had a degree in engineering from Syria. I came to the United States to continue my graduate studies. I continued in the engineering area and basically environmental engineering. I worked through my PhD, and as I was working through my PhD, I started to use computers and fell in love with computers, and that was more than 30 years ago. So now I'm dating myself. Uh, so, I mean, these were the early days of computers, and programming was very different than it is now. So if you wanted to do some programming, you really had to learn some heavy duty, low-level languages. Be able to deal with memory and all that stuff. But anyways, when I graduated, I started working with a company in Ann Arbor that focused on building environmental models for to simulate environmental behavior, mainly for surface water and groundwater pollution. So we continued to write a lot of programs in the process. Of course, we did a lot of field work also. Then I worked for another company, also in the environmental field. Then eventually, there I started to teach myself more diverse areas in computers, mainly in data management, database management, and all that stuff. And eventually, I made the jump to just working in IT. So I kind of taught myself. Uh,
So how
all
do
I
you teach yourself though? Like, how do you teach yourself? Like, what do you like? How do you? What resources? Where do you go to teach yourself?
Well, it's about perseverance. It's about dedication and also a lot of reading, a lot of hard work. Just to give you an idea, when I was working for the first company I worked for in Ann Arbor, I used to go on the weekend on my own time just to learn some of the new computer packages that they had there. I used to go to there used to be a Borders bookstore close to where I lived. So I used to go there. My wife and I used to spend a lot of time there. She's studying for her medical licensing exams, and me just going through computer books. I mean, the ones I like, I would buy and get home. So I went through a lot of computer books, taught myself a lot of programming languages that were burgeoning in that era, that time, especially in the database management systems.
So what
And
were the programming languages at that time when you were learning? Like, can you give us
so
a couple of
the
them?
first one I learned Fortran, which is a more mathematical oriented language very early on. That was back when I was in Syria. I also learned BASIC at that time. I did my dissertation back in Syria using basic programming language on a very primitive computer at the time, one of the very, very early computers. Then here, when I came here, I learned C++, I learned Java, I learned Pascal also. And then
And
uh,
Sam, not to interrupt, when you say you learned computer languages, does this mean you learned how to create programs? Is that what you like when you say I learned the language?
mhm.
What do you actually learn?
So when you learn a language, think about learning French. In order to learn French, you have to learn vocabulary, you have to learn grammar, you have to learn how to use certain expressions in certain contexts and so on and so forth. It's very similar to that when you learn a programming language. It's just now you're instead of speaking with you in French, I would be talking to the computer. I would be basically writing something to some code or instructions to the computer that it can interpret eventually to its own what we call machine language. The machine language is only basically ones and zeros. So your transistors are either allowing for a pulse to go through or not. So that's what the on and off. So that's what machine language comes from. Of course, there were some abstractions on top of that, something called assembly language. Then on top of that, there were some lower level languages like C and then C++, and then higher level languages like Java or C# and so on. All these languages do is allow you to write your code in something close to English rather than something very primitive and very lengthy like assembly language. So instead of writing just like hexadecimal code, which is assembly language, the early assembly language, hexadecimal code is basically uses the hex counting system, just like there's a decimal counting system with digits from 0 to 9. So the hex has 0 to 9 plus A, B, C, D, E, F. So that's where it says hex, plus it's 16 digits or digits, you can call them digits. So anyways,
But before you move on from this one though, you said there are so many different computer languages.
yes.
Like when I think of French, I like the analogy because that's how my brain thinks. There's only one French language, maybe different dialects, right?
Yeah.
But essentially you speak French. If you have so many different computer languages and they're all speaking to a machine, what do they like? Are they like? Help me understand this. Like, why do we have so many languages speaking to
So
one machine?
you can think of those as, just like you said, as dialects, and each dialect has its own interpreter. The interpreter is what interprets that dialect to eventually the machine language, which is the ones and zeros. So you can write your code as long as you're using the right interpreter or the right intermediary layer that basically translates your language into what the machine understands. You'll be fine. Even with French, I mean, you can say the same thing in multiple different ways. Let's say you have some idea, you want to express it. You can express it in a page, you can express it in a paragraph or even a sentence. So with programming languages, some languages allow you to do this, allow you to write your code much easier, much more concise and shorter code. And some of them, no, require you to write really pages and pages to do the same thing. So I mean, there are some differences. Anyways, we can do a whole podcast just on computer programming languages. What matters here to me is I got into some new areas that I didn't know much about, which is data management, which allowed me to jump eventually to just do computer work. So I work for a consulting firm in Ann Arbor that focuses on computer programming. We use computer programming and data management for big clients, especially in the automotive industry, then to healthcare and also in the banking system. And from there, eventually I worked then the .NET era came. And the .NET was a new thing to me. I wasn't mature enough to understand that I could do my own business there. But anyways, I continued my consultation and joined a company that was one of the early like high flyers, you call them, in the internet. That company, I joined it for 3 years. Then I jumped ship to join Microsoft. I worked for Microsoft for about 12 years. During that time, I did a lot of work in strategy. My role was mainly focused on architecture or design. And that design can vary. You can do application design, you can do web design, you can do database design, you can do what we call enterprise architecture, or finally, cloud architecture. And the cloud era started in the early 2010s. And that was really a big thing, big change for us, for everybody in the industry. And Microsoft, even though they came late to the game, uh, they played catch up. And
Why was that a huge game changer?
Oh, because instead of the companies now, the enterprises building huge data centers. Let me just give you a small example. Let's take a company close to your industry, some pharma company. When they want to create a new drug, they want to find a new molecule. They conduct a lot of simulations, and those simulations require a lot of data crunching and number crunching and so on and so forth. So they need to build huge data centers. Like other companies that are similar to the pharma are chemical companies. So one chemical company I was working with, they built a data center that cost them about $50 million to build. Um, and they thought that this is all they needed. It can be enough to do all their calculations. Then they quickly found out that they kind of used all its capacity very quickly. So they needed to extend their capacity somewhere else. Do they build another $50 million data center? There's no end to this. They are in the chemical or pharma business. They don't want to get into the IT business, managing those huge data centers. So instead, the cloud came to solve this kind of problems. So you can delegate your IT management to the cloud provider. The cloud provider will provide you the assets, all the tools, like what we call the virtual machines and virtual networks, all of that stuff, virtual or cloud services in the cloud. You can use all that stuff to build your applications, or you can just use applications that are built by the cloud provider for you. Or you can continue to use your own infrastructure on-premise. But if you need some extra capacity, you can basically, we call it burst, that execution to the cloud. So I mean, there's tremendous benefits of the cloud. The idea of the cloud came actually from Amazon. Amazon, as you know, they started as a retailer, and they used to basically they built a lot of huge data centers to satisfy the holiday seasons. Holiday seasons, they used to have those spikes. Basically, they need to fulfill a lot of orders in a very short period of time. What happened is that those data centers sat idle for long periods of time between, let's say, end of January and end of October. So instead of having them sit idle, they thought about why don't we just like lease these IT assets or this infrastructure to other companies so they can leverage it. And they kind of created what we call cloud portals, which is basically just like a dashboard that allows either Amazon or the customers themselves to create assets on demand and basically run those assets and turn them off. So which allowed for those assets to become like utilities. So you only pay for them when you use them. So that's one of the big tenets of cloud, is allowing you to only pay for what you use and when you use it. So that was very appealing to a lot of companies. And the whole idea took off, and it kind of branched in many different areas. And the cloud providers started to provide even more and more powerful services. One of the latest services that they have been providing in the past 5 to 8 years is AI services. You can build AI tools or applications based on their infrastructure that they provide for you. And instead of you investing huge amounts of money and tons of money to build the data centers that would allow you to do this on premises.
So what example, I mean, when you talk about cloud providers, Amazon, what other cloud providers out there like that you
There
think of?
are mainly different flavors of clouds. Amazon goes into the area of public cloud. Public cloud, that means their cloud is available for everybody, as individuals, as consumers, as enterprises. Anybody can create an account. And once they create an account and subscription, they call it, and that's they can start to use whatever services the cloud provider can provide for them. Another, I mean, the big three providers, public providers, are Amazon, Microsoft, Microsoft Azure is their cloud, and Google, their cloud offering is Google Cloud Platform, or GPC, and GCP. I'm sorry. So, so those are the three main players in the public cloud area. There are other players that are smaller, and they provide mainly more private clouds or specialized clouds, like, for instance, Oracle, IBM, and some other, like, so there are some other companies, but there are also some other cloud providers that provide what we call software as a service apps on top of the public cloud providers. Like, for instance, Salesforce. I don't know if you heard of
Right.
Salesforce.
I heard also,
Uh,
yeah.
so that's what we call software as a service kind of offering, or SaaS offering.
You're right.
The public cloud providers provide different kinds of architectures. Like, one of them is infrastructure as a service, where basically you just like lease what we call virtual machines, and then you can build your own application. You can deploy your own application, or an application that's provided to you by the cloud provider, and run it on that virtual machine. When
Right.
I say virtual machine is, what I mean by that is you leverage the concept of virtualization. Actually, virtualization is one of the biggest enablers of the whole concept of cloud. So that instead of just like having one machine dedicated to do one thing, you can install multiple OSs or operating systems, like maybe Windows, Linux, and Mac OS on the same server, and you can have multiple applications running on it. Each one of those machines is called a virtual machine.
Mm-hmm.
So it's on OS, and on top of that OS, you can run any application you want.
Okay.
So.
So we talked about, I got, first of all, congratulations to teach yourself all of this complexity. To me is fascinating. But you helped me understand the computer and their languages and all of these things. And we talked about the clouds. Where's the AI piece? Still, I mean, none of this is AI yet, right? Um, One is you're communicating with the computer via language and various dialects. I got that. And the computer is responding to you.
Mhm.
And we talked about the cloud and with, all of the information. But AI, I mean, this is making the computers smarter. We're trying to make the computers think like us humans, right? I mean, that's really what AI is.
Well, I mean, AI is not a new idea. You may be surprised. It started shortly after World War II. The pioneer in that area is Alan Turing. He created the Turing machine, which is credited for solving the Enigma, the German Enigma, which played a big role in the Allies winning the war. So Alan Turing, back in 1950, I believe, he basically created what is called the Turing test. What the Turing test implies is, if a machine can fool an expert or a smart person that it is a person, then it has some intelligence. So he came up with this kind of test, Turing test.
Okay, say
Uh,
again, hold on. This is really important. So the
yeah,
Turing test is if I have a machine
or a program, software or
or
hardware.
a
Yeah,
program,
yep.
and that program fools me that I assume I'm actually interacting with a human,
Mhm.
that is the Turing test.
Yeah, that means that machine or that software has intelligence. That's the test. In order for software or a machine to have intelligence, it has to fool you
Right.
that it's actually a person when
Makes
it
sense. Makes
interacts
sense.
with you. But this was taken a step further by, I think, John McCarthy 5 years later, back in 1955. He coined the term artificial intelligence. So he called this kind of
Hmm.
intelligence artificial intelligence. So that's when the word artificial intelligence, or AI, was coined, was started to be used. And actually, there were a lot of early products in that area. Like GM, for instance, created the first industrial robot back in 1960 or 61. Industrial robot that would basically do what a human does. There was a product that was created by MIT researchers called ELIZA, which is basically like a psychologist. Basically, it sits with a human and asks questions about their mood, their well-being, and the human will ask, it will answer and show a lot of empathy. And a
Sam,
lot of,
this is in the 50s and 60s?
yeah, this was 1962 by MIT.
Do you think,
Yeah,
do you think the average listener to this show, seriously, like the average listener to this show, believe that AI was as early as the 50s and 60s?
I don't think so. People will be surprised, mainly
Yeah,
because
I'm surprised.
there was a long hiatus, uh, like that was in the late 60s, between the late 60s and the 90s, where AI development stopped. And I will mention why that happened,
Yeah.
basically. But anyways, the main thing about AI was like, again, in that era, in that time frame, the concept is what we call neural networks or artificial neural networks was invented. And what is artificial neural networks? It's basically kind of some kind of network, as the name suggests, it's networks of neurons and neurons that were called perceptrons at that time. Those neurons are connected together, and they form a layer that you can get information into those neurons, and they can spit information out. So they have input and output, and basically the information they process according to some mathematical equations. Those could be linear equations. These are the simplest ones, for instance, and they can simulate a lot of other mathematical operations or logical operations like and or and so on and so forth. Uh, so anyway, and logical operations and so on. So, but anyways, those neural networks were created at that time frame, but they did not really. They were not sophisticated enough to satisfy uh, rapid development of the technology. Besides, the computers at that time were not sophisticated enough, powerful enough to satisfy such development. And the other factor, we didn't have enough data. Just think of how much data we have now. All the AI models need to be trained. You probably know from your company, there's a lot of training on a lot of data that is involved in those AI models. At that time, in the early 60s or late 50s, we didn't have much data. I mean, basically, the data was locked in books. So that's where people went to find data, or in magazines or journals, and so on and so forth. So that was mainly why AI development kind of came to a screeching halt towards the late 60s. Then in the early 90s, computers started to become more powerful again. And basically new concepts were created. And those new concepts was, instead of having like one layer of neurons, you can have multiple layers. So that the output of one layer could be the input of the next layer, and so on and so forth, which allowed for processing even more complex or
What
sophisticated.
happened in the 90s though, Sam, that we suddenly discovered that you can communicate between neurons, or was there some like, an event that happened and there's like a light bulb that just got
Yeah,
up?
I'm describing what happened.
Yeah.
What happened is allowing multiple layers of those neural networks to be involved. Instead of having like one layer with multiple neurons in it, you can have multiple layers so that the
Mhm.
output from one layer will be the input to the other. That concept was a huge jump in what AI can do. Like I mentioned, you can now simulate or conduct much more sophisticated mathematical and logical functions. Like, for instance, XOR, which is basically another function that was not possible with just one layer of neurons. So anyways, development was still slow, even though computers were much better than the 60s and 50s, but still, in order to develop AI, you needed a lot of data. Still, we didn't have enough data until the internet came. When Web 1.0 came and people started to use the web, then towards the end of the 2000 era, so you can think. Let me go back up a little bit. You can think there were two periods where there was some hiatus in the AI development. The first one is called the AI winter, which is from the late 60s to the 90s. Then there was a slowdown between the 90s and the 2010s. That is not really a winter per se. It's just a slowdown, mainly because we didn't have enough compute power or enough data to satisfy the need for developing powerful models in AI. So once social media became available, once more data was created on the web, just to give you an opinion, Eric Schmidt back in 2012 said that he was the CEO of Google at the time. He said that humanity generated in the past 2 years more data than humanity has generated between the dawn of humanity and 2 years ago.
Wow.
So that's how
Wow.
much data we were generating at that time. And now we're generating even data at a much more rapid pace than 2012. So you can imagine with the advent of the cloud, so the cloud, the huge amounts of data, the compute power, which was facilitated by new generation of chips. So the chips in general, we call them CPUs or central processing units that were like built by Intel or other companies like that. Basically, they were linear in their processing, so they can process. We call them a thread of processing. Then they switch to another thread, and they switch to another thread. But they were basically only able to process one thread at a time. Whereas the new generation of chips is called graphical processing units or GPUs. Like NVIDIA is one of the companies that pioneers those, in addition to others, of course. Those GPUs would allow you to process thousands of threads in parallel, as if you have like thousands of CPUs on the same chip. So that were created mainly, as the name suggests, graphical processing units to support gaming
Hmm.
industry. So if you are running a game, especially if you're running a game online, you want to be able to present 60 frames per second of very, very great looking video and so on and so forth. So that's why those GPUs were very handy. But some smart people thought, oh, those GPUs can also be used to handle AI development, because AI development also requires a lot of parallel processing. So that GPUs, a lot of data, and basically the cloud and the ability to process data very quickly, that all led to an explosion in AI development. So, like I mentioned to you, Mustafa Suleyman, uh, who founded DeepMind back in 2010, I believe, or 2011. So this company created also some games like AlphaGo. AlphaGo is it's basically the Chinese chess that is sometimes called. It's a game that is much more complex than regular chess. It requires basically, if you just count the number of moves in that game, it's like 10 raised to 257 or something like this. So that's how many moves. That number is astronomical, more than the number of atoms in the universe, the known universe. So you can imagine the power of those kind of games. And their program, AlphaGo, was able to beat the world champion back in 2013 or 2014 very easily. Just like Deep Blue from IBM back in 1997 beat the world champion in chess, Garry Kasparov. And since then, no human was able to beat.
I remember the 1997 though, and correct me if I'm wrong, that they had
Yeah,
more than one game, and Gary Kasparov did win probably one, and then
yeah,
he lost another, no?
yeah, that's correct. He won the first one, then he
Right.
never won after that.
Yeah, so this was IBM that they programmed basically the computer just obviously beat the human,
Deep
and
Blue.
then Deep Blue, and then the 2013 was a different thing. This was like a Microsoft thing.
No, this is basically a company called DeepMind
Right,
that
right.
created a program, AlphaGo, which played the name Go, which is sometimes called Chinese chess.
Got
And
it.
he was able to beat the world champion in that game. Anyways, Google bought that company, DeepMind, and now DeepMind resides in Google. Their AI is called DeepMind. So So the development of AI took off at that point. Because of the what we call deep neural networks, I mentioned the multiple
Uh-huh,
layers,
uh-huh.
the huge amounts of data, and the GPUs. All of that stuff facilitated the AI to really I mean, skyrocket basically since about 2011, 2012. The turning point was around 2012 or 2013. There was a regular conference that usually takes place around what we call computer vision. Computer vision basically is the ability of the computer to identify images. Like this image is a cat, this image is a dog, this image is my father, my aunt, my sister, and so on and so forth. So anyways, there was improvement over the past year by the winning programs that exceeded 19%, which is unheard of because usually the improvement from year was like measured about like 1 or 2%. So that jumped 19%, mainly because of the usage of GPUs and
Right.
the deep neural networks. So that basically, again, allowed for AI to take off, mainly in the computer vision area. So there are multiple algorithms that are used in AI. They're all called in machine learning, basically. So there are algorithms in what we call supervised learning and algorithms in unsupervised learning. And then we have something called reinforcement learning. The supervised learning is the one that most people would probably be familiar with, where you bring a lot of what we call labeled data and input that to the model. What do we mean by labeled data? Like let's take the example of distinguishing between a cat and a dog. You feed like maybe 100,000 images into the computer, and you tell it this image is a dog, this image is a cat, and maybe each one of them has a dog in different position, different kind of dog, different breed, and so on and so forth. The same thing with the cats. Eventually, the computer will be able to identify a dog from a cat if you give it an image that is not labeled. So that is called supervised learning. Unsupervised learning, on the other hand, is you give it images that are not labeled. So you give it, let's say, 1,000 images, and you ask the computer to cluster those images. So it creates clusters. Oh, those images look alike. I'm
I
going to
see.
call them dog. And those look alike. I'm going to call them, they have like similar properties. I'm going to call them cat and so on. So that's unsupervised learning. The reinforcement learning is something more sophisticated. I don't know if you are familiar with game theory.
I'm fascinated by it.
Yeah, so it kind of follows those concepts of game theory, basically. So there's some modern algorithms kind of mix between deep learning and reinforcement learning. So like, for instance, between supervised and reinforcement together and so on. So until 2017, there was an event that also led to another revolution in AI on top of what we've already seen so far, which is a paper that was published by a bunch of Google researchers. Um, the paper was called, I think, "Attention is Everything" or something like this. Attention
Mhm.
is all you need. Attention is all you need. What this talks about is basically going through a text, and instead of just trying to recognize the text as the previous models were trying to recognize it in a serial fashion, whatever, instead you can find some what we call tags or certain areas in that text that are related to other areas. And you kind of build those relations mathematically in the form of very huge matrices. So, or basically, they are called vectors. So, anyways, what that allowed to open the door for the next revolutionary technology in AI, which is generative AI. So that's where generative AI came from. And the leading technology in generative AI was large language models or LLMs, which led to ChatGPT. So ChatGPT, I think 3.5 was released to the public in November 2022. That was based on LLMs. And
So can you just maybe in one or two sentences simplify to folks who don't know what LLMs are? Like when you say large language models, I think generative AI probably people are becoming familiar because with ChatGPT, you're creating new content. But LLM,
Mhm.
where's this coming? What kind of LLMs are there, and so on?
So LLMs is large language model, as mentioned. What it does is you feed the model huge amounts of data. Like for instance, ChatGPT is learned on the whole internet, on all the data on the internet, the public
Right,
internet.
right.
What it does, it takes the text and automatically creates those tags and basically creates relations between them and like I said, represents those mathematically and eventually can lead to a way to if you give it a prompt to predict the next word. Uh, you can think of it as an autocorrect, basically, but it's a much more powerful and fancier autocorrect. So
Very
it's
nice.
predicting the next word based on what it learned from all the data on the internet and applying that learning on your prompt, the prompt that you give it. So let's say the prompt, write me an essay on this subject.
Mhm.
You give it a subject name. So it starts to predict the words that should come here and there and there and so on. And then eventually can write you an elegant and a beautiful, grammatically wonderful essay about the topic that you ask it to do. That's the technology LLM, or it's the same, it's basically one of the areas in generative AI. Generative AI is a bigger umbrella that includes creating text, like I just mentioned, or creating videos, creating sound, creating pictures, and so on and so forth. So,
Wow, that's really fascinating. So this is where we are now. I mean, people who probably don't do this for a living, like the lay people, the common public, when they hear about AI, generative AI, they hear about all of this development, it comes to them that humans are being replaced. I mean, essentially, if the computer is going to be smarter than the human, I mean, are we at risk of having certain professions that may be obsolete? I mean, how do we convey that to people who say that? That's number one question. And after you answer that, I'm going to ask you, in every technology, Sam, every technology, and that would be my last question, I promise it's late where you are, but in every technology, it's a double-edged sword, right? I mean, there's always I don't want to say shortcomings, I would say um, there are disadvantages and advantages. Like
mhm.
anything, like the internet, you can use the internet for something very productive, you can use it for something very destructive. So I'd like to hear from you what concerns you about AI? What are the things that say, these are the risks of if AI is not being applied properly or utilized properly by the end user.
Yeah, so there's a lot of work around this area about the risks of AI, especially after the advent of LLMs, and people saw the power that they can bring. So AI is a relatively narrow concept. In other words, AI, let's take Deep Blue, for instance. It's really good at playing chess, but if you play tic-tac-toe with it, you can beat it easily. Uh, but the next step in AI is what we call AGI, or artificial general intelligence. In other words, this is where the machines can think like us humans, where our brain, just like we are talking now, you may be thinking about something else. You may have remembered something else in a different area, and so on and so forth. You may be moving your arms to do something here and there, and so on. So all of that stuff is, in other words, our intelligence as humans is more generic, more general. So eventually the machines will get to that level. And that is the point where they call is AGI. But even then, there will be a point, a lot of researchers predict where AGI or AI will be even smarter than us. In that case, basically, we reach what we call the point of singularity. Just like there's singularity in physics, there's now singularity in AI. At that point, uh, all bets are off. You don't know what AI can do and what we become relevant to AI. This is not something in the near future. researchers vary about when it will happen. It could happen in 10 years, it could happen in 100 years, it may not happen at all. But I mean, most researchers, at least most researchers, say that it will happen. And when it happens, we cannot predict what AI can do or where we will be. And basically, I remember a book called uh, Scary Smart uh, by Mo Gaudat, another researcher that worked for Google and Microsoft. He now has a startup in AI, and he wrote this book. And he kind of resembles this to us working with pets. Like the pet has a certain level of intelligence, but it's not as intelligent as we are. Our pet cannot predict what we are thinking about, what we will do, what our next move will be. They only know certain things. Like when we tell them to sit, they will sit, and so on and so forth. So AI will become, or AGI will become like our master. We may become the pet relevant to it at
Yeah,
that point in
yeah,
time. So
yeah.
again, that's one risk. This is a risk that is attributed to what we call the doomers, and those are led by a guy, Eliezer Ladowski, I believe his last name. This guy is also a self-taught AI researcher. He is a prolific writer in this area. But anyways, AI basically, at least at this moment, the main risk of AI, there are two risks. One risk comes from us humans. Just like you said, it's a double-edged sword. Just like you see social media being used for nefarious things sometimes and for good things in other times, AI could be the same. And at some point in time, there are estimates already that 80% of the users on Twitter, for instance, on the X platform, are not human, are bots. So, and basically, humans can create those bots and they can program them to spread misinformation or disinformation and so on and so forth. So you can imagine the impact of that. The other risk that we see with AI is in terms of jobs. So you just mentioned that some people will lose their jobs. Yes, that is going to happen. Traditionally, in previous waves of development in history, like for instance, take the automation wave in the late 1900s, late 1800s, early 1900s, that was led mainly by Henry Ford when he created his plans, basically where you don't really need to have as many workers anymore. And basically, what happened is at least some jobs were replaced by others. Yes, a lot of jobs were lost, but some jobs were replaced by new jobs that came about. What we're witnessing now is something that is extremely powerful. And even with the jobs that will be lost, even in IT, we will lose jobs. Programming jobs will be lost. Because right now you can ask ChatGPT or Gemini or Llama or any one of those LLMs, and it will write you the most beautiful Python program or Java program. So there will be a lot of job loss. And the thing is, even the jobs that you think you will create that could fit this new AI era, even those could be replaced by AI in the future. And especially now that we're creating humanoid robots or androids that will embed that kind of AI,
Hmm.
like Optimus from Tesla, for instance, as an example. And there are others, many others as well, that are being created now. Eventually, I mean, it's just that the outlook this time around for jobs is not great. In medicine, there's still going to be need for of course, for doctors. There's going to be
I
impact.
don't know why.
Well, let me tell you why. I mean, at least initially, there will be some augmentation kind of work for what you do. Like you with the AI partnering together will do a much better job than just you by yourself. And of course, you by yourself will do a much better job than AI by itself. But what happens is uh, uh, by partnering with AI, you will increase your accuracy and your efficiency. There are a lot of studies already that have happened that show that reading X-rays by AI is as good as the best doctor.
Yeah, I mean, I tend to agree with you. I think on the surface, maybe in the short term,
Yeah.
Probably, but I think honestly longer because to your earlier point, what you taught me already in this 50 minute is that you train the models. I mean, you're really training the computer, and with time, the computer is going to actually know basically particular diagnosis and so forth. And all of a sudden, I may not be that much needed. I mean, I don't know. Hopefully, this is not the case. My last question to you is that what is it that well, let me just frame the question a bit differently. Uh, when you do when you drive a car and there's a car accident on the highway, people talk a lot about this. It's tragedy. If there's an issue, if you miss a diagnosis, because unfortunately sometimes things do get missed. We are humans. It's could be tragic depending on what diagnosis you missed. However, when AI does that, it's augmented differently. In other words, if there's a car that's driving by its own without a driver,
Mm.
and it just operates by its own, and it has an accident, you hear this all over the news because the expectation from AI, Sam, is that we need zero error. If there's a computer that's making a diagnosis or reading an X-ray and telling you that this particular thing is abnormal with more accuracy, if it misses that, it is awful. But if the radiologist misses that, well, human error always happens and 100% accuracy is not expected. Now, maybe this is our brain thinking that our expectation of the machine is you have no room for error, otherwise I'm not going to use it. Is this is this expectation going to change with time? Do you believe that we are going to get to a point where there will never be errors or what we call hallucinations in the AI world? Or is this not expected because the AI is going to be like humans and humans make mistakes and AI is going to make mistakes?
So that's why I said there will be partnership between AI and physicians in your profession. I mean, at least initially, until we get to a point where we almost approach 100% accuracy by AI, which is better than humans. I don't know, you know about the case of the lady whose son had certain symptoms, and she took him to 17 pediatricians that couldn't figure out what's wrong with him. Then eventually she typed the reports from those physicians into ChatGPT, and ChatGPT told spit out the diagnosis right away. It said it's a tethered cord. None of the physicians was able to find that diagnosis. So what I'm saying is that the more powerful the AI models are, the more accurate they will be,
Yeah.
and they will be more helpful to physicians. Like for instance, especially now with EMR and data being connected between hospitals and so on, and healthcare providers, you can do an MRI on a patient, and maybe the AI can look and say, oh, maybe I mean, the doctor might miss something on the corner. And the AI will tell you, "Oh, there's something on the upper right corner
Yeah. Yeah.
that you haven't indicated, or maybe that is different from the way the MRI looked 3 years ago." Then that would, of course, help the physician. Yeah, well, that's why I said it's going to be augmenting
Yeah.
the work for the physician and helping them even do a better job. There's always going to be a need for doctors, but where it can also help is help fill in the vacancy in healthcare system. Like for instance, PCPs. There aren't enough PCPs out there, and especially now residency programs. A lot of people like to go to specialties, like to go to some more lucrative uh, uh, fellowships, and then less and less people go work as PCPs. So how is this going to be filled in the future? By using physician assistants or nurse practitioners that could partner with AI.
Hmm.
Uh, that could be one way to solve this problem, especially like you can think of this as in remote areas in
Yeah.
Africa, somewhere
Yeah.
else.
Yeah.
You can have some skilled nurses that work with the help of AI to fill in the gap where there are no PCPs. So again, there are a lot of areas where AI will have
Amazing.
wonderful effect, but of course, there's the risk. The risk, like if you look at interventional radiologists that those could be probably affected by AI. There will not be a need to as many in a hospital. Instead of having 10, you may only have two would be enough,
Yeah. Yeah.
and so on. So from our
This is
pathology.
amazing. This is a great primer for me and every listener on AI. And Dr. Sam Youness, I cannot be any more thankful of this. Is there anything, again, for those folks who are listening who are beginners, anything you want to leave us with?
Well, I mean,
You basically just told us we're all going to lose our jobs, we're going to be unemployed,
no,
computers
I
will
didn't say
take
that.
over, we'll be robots.
No,
I'm
I
putting
didn't
words
say
in your
that.
mouth. I'm putting words in your mouth.
I didn't say that. What I said is there will be partnership with AI.
Yeah.
We have to accept it. At some point in time, things might be different in the future, at least at the foreseeable future. We need to leverage AI. We need to work with it. All of us, doctors, like for instance, doctors were notorious not to leverage Google.
Yeah.
Like search, Google search would give you a lot of good information. Instead, patients were using Google search and
Sure.
annoying doctors with whatever they find
Sure.
on like WebMD or whatever it is. But
Sure.
now with AI, this tool is available not only for patients but also for doctors. And I
Yeah.
think it's a very good thing for doctors to leverage it moving forward.
Absolutely. Dr. Sam Youness on Healthcare Unfiltered, thank you so much for coming on.
Sure, no problem. My pleasure.